So my project, titled Westward Expansion, primarily focuses on creating jobs and making sure that the working standards for the person working a job is good. In today's world filled with social tensions and a pandemic running rampant, one of the biggest issues an American adult faces is the difficulties of finding a good job that can help improve their living standard. And because of this, the American economy struggles to improve as well. At Westward Expansion, our goal is to produce job openings for Americans looking for work, satisfying our promise to make sure that the job is good and will help improve the standard of living for each working American. How we do this is by establishing various partnerships around the country, filter each worker based on a survey that allows them to select their strengths and weaknesses, and connect the worker to the company, assuring that the probability of the worker being hired is by 100%. This project mainly uses the calculus topic of derivative and second derivative. A derivative is a function's instantaneous rate of change at a certain point, mostly found in marginal cost, marginal revenue, marginal profit, the extrema, the elasticity of demand, and so on and so forth. The second derivative is a derivative of the first derivative, mostly found in acceleration of sales, finding inflection points, finding concavity, and many more. Here's the chart showing all 12 months, and as well as how many jobs are available. So increasing at some points, then decreasing and increasing again. Here's the mathematics showing the chart and the window. The x-axis is months and the y-axis is the jobs available. The cubic regression is this equation right here. This data is based off the graph on the previous slide where the input is months and the output is jobs available during that month. And the cubic regression function will help us find the total jobs available in a given month. Here is some of the calculations on mainly month 4 and month 9, which is some of the busiest times. And according to some calculations, months 7 to 12 are the months in which the acceleration, aka the second derivative, of jobs available is positive. This means that the rate of change is going to be increasing, and months 1 through 6 is going to be where the acceleration of jobs is negative, meaning that the rate of change for jobs available is going to decrease. Over the course of this project, I have learned that mathematics have uses outside of calculating sales, prices, and other uses of currency, making this topic go from what we believe to be unnecessary to our education to something vital for us to understand how the modern world works. I also learned that the use of first and second derivative breaks down how a job systems function. This project acted as a primary example, showing how the first derivative can show the rate of change for the number of jobs available, and the second derivative showing the acceleration of jobs increasing and decreasing, being positive or negative. The use of derivatives for this project shows that math not only assists businesses with numbers and understanding when it all may increase and decrease, but even builds the business up and can even break it down if not calculated correctly and cautiously. Overall, I have learned that the use of calculus in the world of business is critical to its success, but it can also be the reason for a business's destruction if not utilized correctly. And finally, the economic impact. The use of westward expansion will allow jobs to be created for Americans looking for work. The increase in jobs available for the citizen in this nation will allow for the economy to improve over time, and the standard of living for the average citizen to improve across the country. The goal of westward expansion also focuses on improving working conditions on jobs, allowing workers to have an easier time making good performance with the task in the job, and overall improving the job and the economy. Thank you very much. Bye-bye.